Now, when the question asks you to find the magnitude of component of vector A along vector B, what is this about? Maybe you can make a note of this as well. So component of A along B, well, when you say magnitude of component actually means the scalar component, right? The scalar component. So the scalar component of vector A along vector B can be understood as the scalar component of vector A along, so along B actually means along the direction of vector B, right? The direction of vector B in turn, so what I mean is along B implies direction of along the direction of vector B. Now, along the direction of vector B, what is direction of vector B? It is B cap. So along the direction of vector B means along B cap. What is B cap? It is vector B by modulus of B. So A along vector B cap becomes A along B vector B by B cap, vector B by modulus of vector B, which gives us A dot B by modulus B. How is it scalar? Because A dot B gives a scalar. Vector of magnitude of vector B is again a scalar. So scalar by scalar gives you a scalar further. Okay. So is this familiar to you, this expression here? Oh, come on. We just did one question back, right? So this is actually the magnitude of component of vector A along vector B is actually the magnitude of the projection vector. Maybe just I can make a note here. It's actually the magnitude of the projection vector, or is in fact the projection itself. Okay. Now we have two vectors, vector A and vector B. The magnitude of the scalar component would be vector A dot vector B by mod B. What is vector A dot vector B? 2i plus 3j minus k. My bad, it should be dot here. Dot I plus 2j plus 2k. 2i dot I would be 2 into 1. Okay, I've been writing down this every question. It's just to make sure that you don't, if you're here for the first time, I just don't want to, I just don't want you to miss out on the concept. So if it's 2i dot I, right? It actually gives you 2i dot 1i, which further gives you 2 into 1 times I dot I. What is 2 into 1? 2. What is I dot y? I dot I? I dot I is magnitude of I into magnitude of I into cos of angle between I and I. This is vector I. This is vector I. The angle between them is theta is equal to 0. So that becomes cos 0, which further gives us 2 into I dot magnitude of I into magnitude of I is 1 dot 1 into cos 0 is 1. So that gives you 2. Okay. Right. Similarly, we have for J and the K components. Now, 2 into 1 is 1, 3 into 2 is 6, minus 1 into 2 is minus 2. Magnitude of vector B is root of 1 square plus 2 square plus 2 square. So this further gives us 2 into 1, 2, 3 2s are 6, 2 into 1 is minus 1 into 2 is minus 2, 6 plus 2 is 8, 8 minus 2 is 6, root of 9 is 3, 6 by 3 is 2, 6 by 3 is 2, and therefore the magnitude of component of vector A along vector B will be 2. Okay. Now, yes, no, we are not yet understood the concept of the physical application of this concept, which is component of vector A along vector B. So we'll go through a couple of examples and then try to understand what does it mean, or what does it hold in a physical sense. Okay. So what we'll do is we'll go through two examples. One would be the wind, and two, like I said, would be the role of acceleration due to gravity on a inclined plane. Okay. Yes, feel free to skip it because these are just concept add-ons. But if you spend maybe 5 to 10 minutes, or if you watch it in, I think more than 5 to 10 minutes, and if you watch it in 2x, it will just take you hardly 5 or 10 minutes, right? But the concept that you, but the insight that you get out of it would be really helpful in understanding the theoretical concepts that we will discuss further in the chapters work energy power and in laws of motion. Okay, right. So moving on to the next one.